What's up? Daniel here, back with another video. Today I'll be getting ChatGPT to explain classes to me, like I'm 3 years old. No, I'm kidding, but it will be explaining classes in detail. So here I've asked it a question. Tell me everything I need to know about interfaces with classes and TypeScript. So we'll be going into that type of a detail. So without further ado, let's get into it. In TypeScript, interfaces and classes work together to define the structure of object and provide a way to enforce certain shapes and behaviors in your code. Let's go through the key concepts related to the interfaces with classes in TypeScript. Interface declaration. Interfaces are used to define the structure of an object. They don't have any implementation. They solely focus on the shape of the data. You can declare an interface using the interface keyword as such. So we can just go straight ahead and say interface is name it whatever, property, and then the method. So you'll store properties as well as the method inside of the class. So this is how our class would look like. My interface class. So I'll just say this is not what I wanted to do. Okay. Interface, my interface class. So what do we do? Property. So can I say private property1, which is a string? No, I cannot. I guess you cannot do that. Goodness me. Property 3 will be a function that returns void. Like so, right? Okay, there we go. Class implementation. Classes in TypeScript can implement interfaces. This means that a class must adhere to the structure specified by the interface. You can use implements keyword to indicate that a class follows a particular interface. So yes, this is what we did in the last video. Implements follows a particular interface. Yes. So I'll just copy this and then I'll manipulate whatever I need to. So my interface class is what I changed. Property 1, property 2, and my method, which is property 3. I'll just name it as so. Property 2 will name it a string, and this dot prop2 should be a string. So everything is a string, right? Now I'm wondering, how about I had named this t, like so? Maybe like that. And maybe this as well, like that. And my interface class would also be t. This would be generic, of course, and I mean I would need to use it somewhere here, right? Let's just say this is t as well, this is t, and prop1 is t, and that's it. Anyway, moving right along, and I can have multiple of these, right? I could have maybe this and you, like that, and this would also be my caps lock. So this would work. No, you cannot find the name you, but it's here. My interface. You. Oh, there we go. So I would need to define two types, although I'm probably not going to use them. Anyway, moving right along. Optional and read-only properties. Interfaces can have optional properties denoted by the question mark after the property name. Read-only properties can be marked using the read-only keyword. So I just want to check before I continue on. So if I had defined or declared these properties over here in my interface, I understand that I need to use them in here. So for example, if I were to say property 2.5, oops, A, property A, right? And then let's say that's the type U. Because it's not in the class, I need, like, this will give me an error saying basically that property A does not exist here. But if I were to do this, then this is optional. You don't need to have it. You can have it if you want. However, I wanted to check if I were to declare my own property A, which is of type U, what will happen? It allows me to add more properties. So this doesn't restrict me to only have these properties in my class that it implements from. So good to know. Optional and read-only properties, read-only, number, optional property. Ooh, read-only property. Read-only properties can be marked with the read-only keyword. Read-only property 3 is a boolean. So if it's a read-only, then I had forgotten to do something on my phone. It'll only take me a second, and I have started it. So read-only. This is very interesting. Let's just say we have property 2, which is a read-only. So that means that, what is a read-only? Let me just ask GPT, what does read-only do in TypeScript? Cannot be modified once it has been initialized. It provides a way to express immutability for properties and elements in an array. Is there no mutable, immutable in TypeScript? I guess there isn't. Where did I see that? Jeez, so many programming languages use the keywords mutable and immutable, or MUT. So hence I had to ask. So I guess it won't be mutated once it is declared. So this is a string, property 2. Let me just have a function that mutate property 2, mutate property 2. We'll have that as a function, and we'll say it returns void, and it doesn't return anything, but property 2 will be equals to fish. I thought that this couldn't be done. Okay, maybe I'm mistaken. Let me see. Oh, okay, there's more. All right. So in TypeScript, the read-only keyword is used to indicate that a property or an array can be modified once it has been initialized. It provides a way to express immutability on for properties and elements in an array. Read-only properties. When applied to a property, read-only ensures that the property can only be assigned a value during object creation or within the constructor of the class. After that point, attempts to modify the property will result in compilation errors. Compilation errors. Interesting. So, with that being said, let's try it. See if we'll get compilation errors, unless I am not doing what I'm supposed to do. Let me try that again. Okay. I think, let me just get rid of this here. Okay, there we go. I thought that this would also work if I had, you know, defined it over here, but I guess it doesn't. It only works in the actual class. So, okay, now that makes sense. Let me just continue reading about read-only properties. Right, so the class read-only, boom, 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 read-only dot value. Can you do this? Oh yeah, you can in the constructor. After that, you cannot do anything. You will get a compilation error. Good. Read-only arrays. When used with arrays, read-only prevents elements from being added, removed, or modified after the array has been initialized. Read-only number. Oh, okay, that's interesting. You can't do push because already it's saying that, hey, push does not exist on type read-only number, boom, boom, boom. So you can't do anything. But if you remove this, then you will be able to push. So that's good. That's good to know. I didn't know that. That's why we're doing this whole video tutorial session, because there are a lot of things that I don't know that I know you don't know as well. So read-only arrays. When used with arrays, read-only prevents elements from being added, removed. Okay, we've passed this. We can't do none of this stuff. Can't even pop. It's important to note that read-only provides a form of compile time immutability, but it does not prevent all forms of mutability at runtime. For example, if you have an object property marked as read-only, the properties of that object can still be modified if they are not explicitly marked with read-only. So you need to specify for each and every single property in an object. So this, but prop1 inside of my object is mutable. So this dot object prop1 value, this dot object dot prop1 equals new value. This will work. Okay, that makes a lot of sense. Okay, so can I move back to my initial linear style learning sequence, which I was here at read-only, right? Oh wait, I was at read-only, but interfaces can have optional properties such as this. Read-only. This doesn't really work. Extending interfaces. Interfaces can extend other interfaces, creating a new interface that includes all the properties and methods from both. Ooh, extending interfaces. Interfaces can extend other interfaces, creating a new interface that includes all properties of both. So my interface, another interface, inherits properties and methods from my interface and another. So what happens now when you have these two interfaces? What happens if they have the same method names or something like that? So let's just see my interface class. I'm gonna say my interface class 2. My interface class 2, which will be of type T and U, and property, let's give it 4, let's give it a string, whatever. Let's just fix that. But then now let's give it property 3. Okay, I guess this will work. implements my interface class, and just my interface class 2, and the types will be T and U, and that should work. It does work. Nope, it doesn't. My class incorrectly implements interface my interface class 2 TU. Property is missing in type, but required in type. Boom. So I'll sort that out. Okay, I don't know what they're saying. Property 4 is missing in type my class TU, but required in type my interface class. Oh, property 4. I don't have property 4, so I need to. There we go. So now I just want to know if I were to add property 3, which is a function. Okay, let's say my property 3 from my interface class 2 returns a U. What happens then? Property 3 in type my class TU is not assignable to the same property in base type my interface class 2. Type void is not assignable to type U. Type void is not assignable to type U can be instantiated with an arbitrary type which could be unrelated to void. So can I say it's maybe void or it's U? No. Property is the same problem. We have the same issue. It's not. Okay, so this won't work. So I guess lesson of the day, don't double define, right? So keep it a B. Alright, that makes sense. Moving right along. Abstract classes. I already did this. Wait, let me see. Implements, okay. The keywords works for both abstract classes and interfaces. So this is abstract classes. Abstract classes can also implement interfaces. Abstract classes cannot be instantiated directly. They are meant to be subclassed. Subclasses must provide implementations for all abstract methods defined in the interface. Cannot be instantiated directly. That makes sense. You need to use it in another class, or you don't use it at all. So in this case, we have my abstract class. Oh wow. So in this example, they use an interface for the abstract class, but they don't do anything with it. Wait, what? Abstract classes can also implement interfaces. That is worth taking a look at. Okay, so I'm just gonna create a new class, and I'm gonna create an I'm just gonna use this interface, and then I'm gonna, okay, let me just keep that here. I'm gonna create this, I'm gonna implement this. I'm gonna create an abstract class, and I'm gonna implement this interface, and then I'm gonna create another class that's gonna use the abstract class. Because you cannot instantiate an abstract class. So let me just do that. How would I go about this? So create an abstract class. My abstract class implements my interface class with the following types t and nope with the following types t and dude, it's my computer. My abstract class. I wonder what this is. So I need to have these for generics as well. Oh, missing the following properties. Yes, we will add those. And it's property 1. I'll just copy these really, and I'll paste them here. And really, I just wanted to understand something about this. Well, this won't go here. So I can have a constructor. Obviously, it doesn't do anything. Subclasses must implement this method, abstract method. So do I need to specify that it's an abstract method? Why can't I just say method, since it falls under the abstract class? So clearly they know that it's a method that they need to implement, right? The subclass. Anyway, I guess not. Let's do the constructor. Constructor property1 is of type t, and then property2 is of type string, and then this dot property1 equals property1, and then this dot property2 is also property2, and let's define an abstract method. Geez, what's this? Property 3, yes, property 3 is a method, and we're gonna define it right here. Property 3 void, and what does that return? Wait, I don't have to implement anything. Abstract. There we go. It's abstract method, so I guess you do need the keyword there. And with that being said, that should do it. But now we need to actually use this abstract class. So I'm going to create a new class that's going to use the abstract class. So how would I go about that? I'm going to say I'm going to create a class. So class user of abstract class. User of abstract class implements. Is it implements the keyword? Let me just go back in one of my old shape. Circle implements p, but how do I use the abstract? I think I just implement. Let me just implements my abstract class, and I think there we go again. T U, and I think I need this for this as well. And I think with that being said, before I even continue on with my class, can I make use of multiple abstract classes, just like how I can with one class that implements multiple interfaces? Can I actually, use, I don't know, I'm just thinking, I mean, I could just copy all this code, since that's what I'm doing, and then instead of this abstract, now I actually need to implement. It's just console.log water and user of abstract class. So let's finally use this class. So what we would do is let, or maybe const I don't know, user equals new user of abstract class, and we'll pass in t, which is I don't know, string, and then u, which is a number, and then Daniel, and 100. Does that not work? Number. Of type string. How do we know that it's of type string, guys? Oh, it is of type string. So let's just say this is 100 and this is Daniel, whatever. This is also a number. Let's say this is, we gave it number, right? So t is number, u is number, but then property 2 is a string. So that's how this is a string, and it was giving us an error because in the constructor of this, as you can see, we have string here. If this was u, then we wouldn't have a problem. Is it there? I don't think it's there. It's actually here. Yeah, not that. Yeah, it's here. I could change this. I could make it a u, and I could make this a u, and then probably 2 would also be u here, and this will be u, and this could now be a string, just like that, Daniel. So it's property 2. So now I can console log dot log. I can console log user dot property 2. It's public, right? What? The u is not assignable to type string. Property 2 is not assignable to the same property in the base type, my interface to u. The u is not assignable to type string. The type parameter might need an extends string constraint. What? Wait, let me think. This is read only. I'm not using this, right? My interface. Okay, I am. This is a string. Let's convert that. This is property 2. It's a read only. Will make you a string. Property 2 will make you a string, I mean a u as well, and then everything, because everything is kind of interconnected over here. And then now I think everything should work. So we'll try and run our compiler. It works. Anyway, constructor signatures. You can define the structure of a class constructor in an interface. This allows you to enforce the class's implementing. Sorry, I nearly thought that I wasn't recording there for a moment. You can define the structure of a class constructor in an interface. This allows you to enforce that classes implementing the interface must have specific constructor parameters. Oh, interesting. So let's see, interface new param1 string param2 number for my class. So like now in an interface I can keep enforcing. I get this. But now do I have, this is property 1, property 2 for user of abstract class. Can I create an interface create interface to add constructor constraints. Let me do that. Interface constructor constraints. Constructor constraints, we'll say new, we'll say, what is this, property 1, property 2, property 1, property 2, what's the type? This is of the type u. Do I need to clear the type or define the type? Sorry. Type u, type t, so this I guess will have type t and u, and then this will go in constructor constraints t and u. Okay, there we go. So I was missing this user of abstract class. No? Do I have to have the types here as well? Provides no match for signature new. Property 1, property 2 u. What's going on? Let me think. New as my interface implements my interface param. Let me just try and do this. Implements. No, still have a problem. Class user of abstract class. TU incorrectly implements interface. Constructor constraints. TU. Type user of abstract class TU provides no match for the signature new. Property 1 T, property 2 U. Let me do this because I think it might be a compiler problem, but it's not. Oh goodness, I don't know what the problem is. Let me just go back here and just read this. You can define the structure of the class constructor in an interface. This allows you to enforce that classes implementing the interface must have a specific constructor parameter. And here we have param1 string, param2 number. Param1 t, param2 u, tu. I don't really understand. Let me just try and get this error. Just try and get this error. In number 6, I'm getting this error. Let me do this. Is this code correct? The code you've provided looks mostly correct, but there are a couple of points to note. Constructor constraint, your constructor constraint interface. Your constructor constraint interface is intending to define a constructor signature, but it's not quite accurate. The correct way to define a constructor signature is an interface. In an interface is to use the new keyword. Did I not use the new keyword? I just did. Just use the new keyword and call signature. Also, you should use extends instead of implements when using the interface to constrain a class. Here's the correct interface. Interface to new Oh, okay, I see what the problem is. No, it's not the problem. I don't know what the problem is. Oh goodness. Okay. Usage of the constructor constraint. This is exactly my code. Constructor constraints, new property 1t, property 2u, this user of abstract class tu. Okay. Usage of constructor constraint. When you want to use your constructor constraints interface to constrain a class, use the extends instead of the implements. And then he continues to use the implements. That's crap. Okay, I guess ChatGPT is drunk. But there's no way where you use extends, bro. With these corrections, your code should work as intended. Here's the full version. Implements. This is exactly what I did. There is no difference. So I guess there's some sort of error that's happening over here, but geez, this is gonna ruin my night. So I need to understand how this all works, and I'm just gonna leave it as this. And I think I'll work on it tomorrow. Yeah. This is of high interest to me, so let me see. Now I'm very skeptical to continue with the tutorial because ChatGPT is giving me errors. It's not really doing the right things. Implement clause. When a class implements an interface, it must implement all the properties and methods declared in that interface. Typescript will throw an error if any required members are missing. Yes, I understand that. Declaration merging. Interfaces can be merged in TypeScript if you define an interface with the same name multiple times. TypeScript will merge them into a single interface. So this and this will be the same thing. That's good. Good to know. Good to know. So I guess I'm done, but I'll just need to work on this tomorrow. Let me just uncomment that. Git commit. Added classes 5 with errors. Git push. And with that being said, I will see you guys when I see you guys. Peace.